Hello, this is part 2 to the video you just watched because we are adding on a few things and I've recorded it too many times and it didn't work. So this is a quick add-on. So with this right here, going back to slide 3, we want to talk about what f of 2 means. You already did domain, range, and function in the first part of the video, but now we're going to talk about this f of 2 feature. What does this mean? F of 2 on this graph means this is my x, the whole thing is my y. If I was writing it as an ordered pair, it would look like this. X is 2, what is the y that goes with him? That's what it's asking. So here, if I'm at 2 and I come up, the ordered pair is 2, 3, so 3 is my f of 2. So now on B. It says f of x equals 2. Well, that's different than this. This is my x. We don't know what it is, but what we do know is this whole piece equals 2. So my y is 2. So when my y is 2 and I come across, my x is 3. The difference is he's giving me the x here, we're finding the x here. It's understanding with this notation that this f of 2 just means the function at 2, and again, because x is my input, everything is driven by him. So here on C, we have f of negative 2. That means when my x is negative 2, what's my y? So when my x is negative 2, my y is 0 because the ordered pair is negative 2, 0. Again, here, I don't know what my x is. What could he be? But I know that the whole y equals 2. So when y is 2, my x is 0. And then here, when my x is 4, 1, 2, 3, 4, what is my y? 3. Makes the ordered pair 4, 3. The other piece that we are adding on to this, is one other page later, right down here. We talk about these parent graphs and the shrinking and the moving and all that stuff. This has also been added on. So let's talk about this and see what's going on. When I want to shift up or I want to shift down with a shift says I'm taking whatever the original equation is, and to go up, I'm going to add some kind of number. So it might be x plus 3. I went up 3. If I'm going down, I'm going to subtract that number, like x minus 3. That's a shift of my graph. Remember, we're shifting on the y-axis, going up or down on my y-axis. The next thing we're going to talk about is when we have a number in front of this. This number is going to do certain things in an equation. Now, in the picture, we have to kind of figure out if that number's there or not, but if I have a quadratic or an exponential graph, that number in front is going to stretch or compress the graph. How do I know which one? Well, if this k is greater than 1, which means he's a whole number, then it's going to stretch it because it's going to stretch it and make it skinny. That's what it does. It makes it skinny is what it does. To compress, my k is less than 1 or it's a fraction. So if it's a fraction, he's going to be really wide. That's compressing it. Because you're talking about getting this way, compressing and making him wide, or pulling him really, really skinny by being greater than 1. The last one is a reflection. A reflection just says, hey, whatever this k is in front of this, if he's negative, he's going to reflect. This piece means the reflection, a negative k. Back to here, sorry, when we're talking linear, I lost linear. Sorry, linear, he's going to be more steep which means he's going to be k is greater than 1. So that's like a slope of 3, 4, 5. He would be less steep if k was less than 1, like a half, a third, a fifth. He'd be either like this, really steep, or really flat like that. So let's look at these two here and see what comes out of this. This is on the notes that we gave last class. So here, with this right here, we want to talk about the parent graph. So first of all, he's a line. So the parent graph from a line is just y equals x. He is the perfect graph with a slope of 1 that goes through the origin perfectly. Now, if I was a nice drawer, I would have used a ruler, but it doesn't matter because I'm just sketching to see what my parent graph looks like. So with this right here, when we're talking about the domain, he's the same domain we talked about before, all real numbers. When we're talking about the range, how wide he is, again, all real numbers. My x-intercept is where he crosses my x-axis, which is also my 0. Remember that. He's going to be at 5, 0. My y-intercept right there is 0, 2. That stuff should be easy schmeezy. But now when we're looking at the graph to see if it shifts up or down, if my parent graph in pink and my black graph is my new graph, he obviously went up 2 from the center of the grid. So he shifted up 2. That means his equation would have had a plus 2 at the end of it. Now looking at my slope, I went up 1 over 1, up 1 over 1, up 1 over 1. Here, I went up 1 over 2, up 1 over 3. I guess I didn't really go over 2. So up 1 over 2. Should be up 1 over 2 if it's a perfect graph. So here, he's actually going to be less steep. Less steep, because a 1 and 1 would be my normal graph. He's going to be 1 over 2 or 1 over 3, which makes him a fraction. So he's going to be less steep. Now, is he reflected? Well, yeah. This guy's a positive slope, this guy's a negative slope, so of course he's reflected. When you're given the picture, it's a little bit harder to see about the steepness. But you got to kind of look at him. Is he really stark or is he really flat? Now this one here is our quadratic. How do I know? When I put him on Desmos, here, I'm going to have a graph. I'm just going to make him blue. I think it's 1, 2, 3, 1 and 4. He's going to look something like this. A little skinny. My regular one is a little bit wider. He's going to look something like this. How do I know what's going on? When I'm just looking at these guys on the bottom, first of all, my new graph is skinny. So he, because he's skinny, it's going to be stretched out. He's skinnier. He's stretched vertically. Okay? How do I know that as well? I have a whole number right there. That means I've been stretched. Remember, the fraction means I compressed. I'm 4 times as what I was, but I didn't give myself any extra material to do it. I just stretched it to get it there. I'm also going to be here, because I have this negative, I know I've been reflected. Plus, looking at my graph, I'm on top of each other. We did not shift left or right, and we did not shift up or down. But this is important right here. My new graph looks like this. Remember we said that makes him a maximum of my graph. He's the highest point available. If not, a parabola, it's only in our parabola, which is our quadratic, this right here would be a minimum because it's our lowest point on our graph. There is a question about whether he's a maximum or a minimum, which was all in our homework as well. The lowest point is a minimum. The highest point would then be my maximum. Then these guys are just the same that they've been. Looking at my graph here, he's going to go on and on and on forever and be wide. So again, he's all real numbers. My range, he's going to start from here and only be down. So my y is less than or equal to 0. And my x-intercept and my y-intercept happen to be the same number. Look at those notes and study that middle bar graph on how these things change. Remember, they're generic questions and you can see them on Desmos. Have a great day.